In this lesson, we're going to learn how to estimate square roots to the nearest tenth. In the previous video, you learned how to estimate square roots by looking at what two integers they fell between. So today we're going to go a little bit further and figure out how to round that to the nearest tenth. So in order to begin, we're going to use what we learned yesterday, where we practiced rounding, estimating or finding the two integers that the radical falls between. So the square root of 12, in order to do that, we need to remember our perfect squares. So to generate those, you just need to think 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. And for this one, I can actually stop there because 12 falls between 9 and 6. So I know that the square root of 12 falls between the square root of 9, and the square root of 16, not 6, 16. So if I know that it falls between the square root of 9 and the square root of 16, because 12 is in between 9 and 16, and I know the square root of 9 is 3, and the square root of 16 is 4, then I know it falls somewhere between 3 and 4. So from there, what we're going to do is we're going to use multiplication to try to find whether it's what it's closer to figure out what it would be to the nearest tenth. So if I think about 9 and 12, 9 is 3 away from 12, and 12 is 4 away from 16. So it's seems like right about in the middle of 9 and 16, because it's only 3 away from 9 and only 4 away from 16. So I'm going to guess, since it's a little bit closer to 9, I'm going to start by guessing that it's 3.4 is the closest to the square root of 12. So I'm going to multiply 3.4 times itself, because that's what you do when you square a number. So the square root would be trying to figure out what you multiplied by itself to get 12. And we're not going to get exactly 12, because 12 is not a perfect square, but we're going to try to get as close as we can. So let's try multiplying 3.4 times 3.4 and see how close we get. So 4 times 4 is 16. Carry your 1. 4 times 3 is 12, plus that 1 would be 13. Now we need a placeholder. Now we're going to multiply 3 times 4 is 12. Carry that 1. 3 times 3 is 9, plus 1 more is 10. Add those together and we get 6, 5, 1, 1. And we move our decimal place 2 places because we had a decimal here and a decimal here. So 3.4 squared is about 11.56, which is not too far from 12, but we might be able to get a little bit closer to 12. So let's try 3.5 times 3.5. 5 times 5 is 25, carry the 2. 5 times 3 is 15, plus 2 more would be 17. We need a placeholder here. 3 times 5, 15, carry the 1. 3 times 3 is 9, plus 1 more is 10. We add these together, we get 5, 12, 1 plus 1 is 2, and 11, or 1. So there's also 2 decimals in this problem, so we move our decimal place 2 places over and we get 12.25. So 11.56 is about 0.4 away from 12, and 12.25 is only 0.25 away from 12. So it actually looks like this is closer to being 12. So we would say that 3.5 is the best estimate of the square root of 12 rounded to the nearest tenth. So let's try the same thing for the square root of 20. Remember your perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So 20 falls between 16 and 25. So the square root of 20 falls between the square root of 16 and the square root of 25. So it falls between 4 and 5. And 20 is 4 away from 16, and it's 5 away from 25. So this one seems to be right in the middle of 4 and 5, just like the last one was in between 3 and 4. So since it's closer to 16, I'm going to try 4.4 times 4.4 first, because halfway would be 4.5, but since it's closer to 16, I'm going to go a little bit lower than 4.5 first. 4 times 4 is 16. carry the 1. 4 times 4 is 16, plus that 1 would be 17. We're going to move over to the 10th place, so we add a 0 here. 4 times 4 is 16, carry the 1. 4 times 4 is 16, plus that 1 is 17. We add these up. 6 plus 0 is 6. 7 plus 6 is 13. Carry that 1. Then we have 7, 8, 9, and the 1. And we have to move our decimal place twice because we have 2 decimals. So we get about 19.36, which is close to 20. But let's see if we can get closer with 4.5 times 4.5. 5 times 5 is 25. Carry the 2. 5 times 4 is 20, plus that 2 would be 22. Add a placeholder here. 4 times 5 is 20. Carry that 2. 4 times 4 is 16, plus that 2 would be 18. We add those up, and we get 5, 2, 8 and 2 is 10. Carry the 1. We get 20.25. So 4.5, again, is actually closer to 20 than 19.36 was. So our best estimate is about 4.5. So at this point, I would like you to pause the video, and I would like you to try to first figure out which 2 perfect squares, 42 and 33, fall between, and then restart the video so you can see if you're correct. I would start by listing your perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. So that should be enough to get you started. So what you should have seen is that the square root of 42 falls between the square root of 36 and the square root of 49, which means it falls between 6 and 7. The square root of 33 falls between the square root of 25 and the square root of 36. So it falls somewhere between 5 and 6. So next, for the square root of 42, we're going to figure out which one it's closer to. 42 is 6 away from 36, and it's 7 away from 49. So again, it's right in the middle. So since it worked last time to just do 0.5, let's try just 6.5 the first time around on this one. So 5 times 5 would be 25. 6 times 5 is 30, plus 2 more is 32. Add a 0 so we can multiply the 6 now. 6 times 5 is 30. 6 times 6 is 36, plus the 3 more is 39. We add these up, we get 5, 2, 9 plus 3 is 12, carry the 1. We get 42.25, which is really close to 42. So 6.5 is the best estimate. With the square root of 33, we're going to do the same thing. 33 is 8 away from 25, and it's only 3 away from 36. So it's going to be more than 5 halfway between this time. It's going to be closer to 6 than it is to 5. So I'm going to guess that it's 5.7. That's really all you're doing. Once you know that it's more than halfway between, just choose something that's more than halfway, which 0.7 is more than halfway between. So multiply these. 7 times 7 is 49. 7 times 5 is 35, plus 4 more would be 39. Add a placeholder so we can multiply by 5 now. 5 times 7 is 35. Carry the 3. 5 times 5 is 25, plus 3 more would be 28. Add these up. 9 and 5 is 14, carry the 1. 8 plus 3 is 11, plus 1 more is 12. Carry the 1, we get 32.49. So that's pretty close to 33, but I would like to check if 5.8 is any closer. So I'm going to try 5.8 times 5.8 and see if I get closer to 33. 8 times 8 is 64. 8 times 5 is 40, plus 6 more is 46. Now we're moving to the 5. 5 times 8 is 40. Carry that 4. 5 times 5 is 25, plus 4 more is 29. Add those up. 4, 6, 9 plus 4 is 13. Carry the 1, we get 33.64. So 33.64 is 0.64 more than 33, and 32.49 is actually closer because it's only like 0.5 away. So for this one, I would actually go with 5.7 being the best estimate. So I would like you to try to estimate which statement is true about the square root of 37, and then you're going to give your opinion of whether 8.5 is a good first guess for where the square root of 72 would fall. And for both of these, you should be thinking of your perfect squares. 1 squared is 1, 2 squared is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. 8 times 8 is 64, 9 times 9 is 81. That should get you what you need to be able to figure out about where these numbers fall, which two numbers they fall between, and then estimate from there.